Good morning, madam. Krishna Kumari, madam. Good morning, madam.
Good morning, doctor.
Yeah. Good morning, professor. You are the first guest. Krishna Kumari, madam.
Hello.
Ma'am?
Hello, sir. Good morning.
Yeah, you are audible, ma'am. You are audible. Good morning, madam.
Morning, sir. Morning, sir.
Welcome, madam.
Thank you so much, sir.
Thank you for accepting our invitation, madam.
First of all, thanks for giving this opportunity, sir.
Yes, ma'am.
Yeah, nice talking.
We'll start sharply at 11 o'clock, madam.
Yeah, sure, sir. Sure, yeah.
Yes, thank you, ma'am.
Okay, thank you, sir.
Yes. Good morning, madam. Krishna Kumari, madam.
Hello, sir.
Yeah.
Shall we start?
Yes, madam. Shall we start, madam?
Yes, sir. Yes.
Yeah. Yes.
Yes.
Good morning to one and all present here. We are now going to start the session. We cordially welcome our highly respected chief guest, Dr. G. Krishnakumari ma'am, of this session. The topic of the today's session is Importance of Mathematics in Science and Technology. Now I invite Dr. T. Gunashekhar sir to address the speaker.
Good morning to all. I, Dr. T. Gunashekhar, Associate Professor of Mathematics, School of Science and Humanities, Weldtech University. I am glad to introduce our research person of the session, Dr. G. Krishnakumari Madam. Currently, she is working as a professor and head of the department, Freshman Engineering, Varadan College Engineering, Hyderabad. She has more than 25 years of academic research and administrative experience in various reputed institutions. Also, she is a guest faculty of BITS Planning. She is holding various administrative posts like Vice Principal, Dean Academic, and Head of the Department in KL University, Hyderabad. She is contributing service as Board of Studies Chairperson of Mathematics, Academic Council Member, Institution and Innovation Council Member, Professional Body Member of International Association of Engineering, Universal Association of Computer and Electronics Engineers, Computer Science Technique Teachers Association, Indian Mathematical Society, designed a curriculum for various courses of mathematics and data sciences. She is also acted as a coordinator for NAAC and NBA accreditation. Also contributed services to outcome-based education, problem-based learning, honors degree, contributed service to Skills Development Center. She is preparing the ornogram rules book, HR policy, and the standard operating procedure at KL University, Hyderabad. She has obtained her graduates, undergraduate and postgraduate from reputed universities with gold medalist. She is received from her PhD from Usmania University, Hyderabad, Telangana, 2011. She completed MTech Software Engineering from BITS Planning with the specialization of data analytics. She is also has qualified CSIR NET Mathematics. She is graded PG student and research scholar. Her research contribution are minor project by UGC. She has filled and published various national and international patents. She has published 40 research articles in the reputed international journals like SCI, Web of Science, Scopus, UGC, CARE journals. Also, she has participated and presented a huge number of research articles in the various national and international conferences. She is a technical committee member. Also, she is acted as a section chair for the various seminar, national and international conferences. She is acting research person in the various workshops, FDP and webinars. She has also organized many guest lecture, workshop, seminars, motivational section in many reputed organizations. She is also an editor and reviewer in the reputed international journal. She was honored by the institution for excellency and contribution in various fields of life. Academic leader awarded by International Institute of Organized Research. Academic administrator awarded by CSR Awards. Women Excellence Award for Best Academic Administrator Award by IDLC AMP 2020. Best Inferring Teacher Award from the Teachers Academy 2010. We are very delighted to welcome you on this wonderful session of this online summit of International Faculty Development Program and current trends in applications of mathematics. Thank you, madam.
Now I hand over the session to Dr. G. Krishna Kumari, ma'am.
Thank you so much, sir, madam, for a great introduction about myself. Yeah, thank you, everyone. Let us start the session.
Yes, madam.
Yeah, yes, sir. Good morning, everyone.
Good morning, madam.
Good morning. So anyhow, my introduction is already completed in a long way. Thank you so much. So first of all, let me give my information why I have picked this topic, importance of mathematics in science and technology. The basic reason behind that is 2023 World Mathematics Day. March 14th, 2023, World Mathematics Day will be there. For that, the theme for that particular year is mathematics for everyone. So mathematics is for everyone, and everyone will be using science as well technology in one or other way. Everyone is having cell phone, everyone is having TV, whatnot, all electric, electronic, and every gadgets we used to have nowadays. But the point is, in what way maths is related to the science and technology, or what all we are using in daily life. And nowadays, we are talking much about artificial intelligence, much about machine learning, much about data sciences also. So everyone knows that maths or statistics, they are playing major role in all these concepts. So what is that importance? Why we are saying that these topics are very important, or maths is very important for these areas especially. And also not only this artificial intelligence as well, data science and machine learning, in almost all engineering, not almost, every engineering branch definitely must use mathematics. Every research area must use mathematics. Without maths, there is nothing. So in that scenario, I just wanted to pick this topic based on this 2023 theme, International Mathematics Day theme. What is the role of mathematics? In what way we consider maths? In which aspect we see maths? It is autonomous intellectual discipline, created power of human mind. Also, it plays a fundamental role in modern science as well, engineering and technology. In other way, we see maths as an art in its own direction, because it creates a lot and it itself designs. We always call as mathematical modeling, simulations. So it is an art. It is a game that is played in our minds. Always we think about the logic, analysis, results, how we get the result, in what way we have to analyze this problem, what logic must be used in this. So all these are related to the game playing in our mind. And as discussed now, reasoning and analysis play a major role for the competitive problems as well, many examples in the real life situations. A very important part of math, which is taught in our universities all over the world, devoted to the education of these following. Not only these, many more also there. Like this is devoted to engineers, physicists, chemists, computer scientists, economists, and nowadays economics as well, financial marketing, and especially in share marketing, if we consider moving average methods, moving averages, also convergencies and divergencies, and other KDJ models. For all these, maths is necessary. Now, if you observe this candle here, this is very much considered for share market. Those who are aware of this share market can easily identify these candles. Just a moment. Yeah. Now here, if you observe, what is the starting amount of that particular day, where it is starting, and what is the closing amount, and in between, what is the real body, how it is fluctuating, whether it is a positive candle or it is a negative candle, and in a particular period, let me suppose a week, or let me suppose a 3 days of period, how it is moving, whether the price is increasing, price of the share is increasing or decreasing, or it is very neutral or constant. Okay, so all these data, especially if you consider this real body, here we can go with linear as well non-linear curves also, bar charts. So all these are used for this share market. Not only share market, even for cricket analyzations, pitch as well, wickets, everything. And in the last decades, we have seen the trend towards mathematization reach other disciplines like economics, financial market, and so on. In what way these are used? For example, if we consider the operations research, queuing theory, inventory models, transportation models, job sequencing models, investments, employment, and demand supply models, price production levels, for all these, maths is very much used. If we consider this economics part, linear curves or linear functions, non-linear functions, quadratic functions, total cost functions, inverse functions, and exponential functions. All these are very much depending on mathematics as well statistical logics. If you observe here how these graphs or lines have been drawn and what is the formula, and everything has been given in this. So the major application of mathematics is there in real life situation. Also, not only this, branches of chemistry, biology, as well medicine, social sciences, everywhere maths is used. Let us discuss all this in the upcoming part. Now, the softwares. The capabilities of scientific computation made numerical simulations an indispensable tool in the design and control of the industry process. Now see, suppose a small data is given, let me suppose a 10 or 20 data set is given, points are given. Manually, we can complete that part. For example, if you are doing a research or if you are in an industry, you are doing an experiment in a large scale. So 1,000 data set points may be there, or 2,000 may be there, or beyond. In such situation, manual calculations or simulations is not possible. So obviously, softwares are used to get the results. So like MATLAB, Maple, Mathematica, SPSS, whatnot, many other softwares also available. Let us give a glance on this part, what all softwares are used for this. And just one moment. Yeah. Mathematics softwares and what is the application? First one, computer algebra systems. The application part is systematized, monotonous, and problematic algebraic manipulations task. The second software, axioms, mathematical expressions to the traditional manual computations as per the expectations of mathematicians as well scientists. Maxima, which is used for computer algebra systems. GAP and CIRCA. These are for discrete algebra and computational graph theory. One more, Cadabra for field theory as well algebra also. Computations in commutative algebra. And the application is multivariate polynomials. If you observe the right side part, everywhere mathematical area is involved into these softwares, directly or indirectly. And more, SciPy, all of us know nowadays every person is using Python. Python programming language library to take the advantages of Python's ability to handle large data sets as discussed now. GNU plotting as well OpenG also. See, these two softwares are very much useful for graphing program with extensive graphing features. Especially this is used for OpenG as well. GNU plotting is used for computer graphics. And I will show at the end how graphics will be. and what kind of maths is used for computer graphics. Next, SPSS, statistical analysis for software data. R programming, all of us know this. R is both a language as well as software used for statistical computing and graphing. SAS math, alternative to the general purpose for the mathematics products, Maple as well, MATLAB. PARI or GP, number theory computing, factoring, algebraic number theory, and analysis of elliptic curves. SymPy, the other software, computer algebra systems written in Python, that is the specialty of this software. Octave MATLAB, high-level language with the primary intention in numerical computation. Especially nowadays, the scholars as well professors, everyone is using MATLAB as well Mathematica for their simulations. Now, actually, no one thinks perfectly or poorly all the time. This one everyone knows. Why I have quoted this point, the reason behind that is probability plays a major role in mathematics. Probability, the name itself says 50-50. So, perfection we never expect. Always we expect optimization. So, no one thinks perfectly or poorly all the time. So, always improvement will be there. When we do our research this time or this year, probably the next year, modifications will be there and more sophisticated methods may be there in the market based on the research and innovations. And lot of, actually this is a creative world. Lot of creativity is there and most of the people, they are continuing their research and they are identifying the new softwares as well. Lot of development is there, right? Now, memorizing something is not the same as thinking about it. So thinking is different, memorizing is different, all of us know. So we have to depend on thinking. So what is that? What type of thinkings are there? Now, if we consider intelligence as well thinking, there are three main types are there under this category. Those three are analytical, creative, and practical. All of us know all these 3 points. So how do we define a problem? How do we analyze that? How can we create the next modeling part or simulation part? And how do we solve it practically? How do we solve it? How we interpret the results? This is what we do in research. First, I'll show that also, just a moment. Now, we can improve our thinking skills by understanding the process involving in thinking. So we have to continuously, we have to improve our thought process. And that thought process will be aligned with our research, what we are doing. So obviously there will be improvement in our thought. So whenever the improvement in the thought process, automatically the creativity will be there. And obviously the problem definition will be definitely categorized as well as tailor-made and improvement will be there. So we must understand the problem. We connect all those concepts to each other. We categorize them, manipulate them, put them together in new or novel ways and apply them as we seek new solutions to new problems. This is the concept of the research. Now, how do we define a problem? How do we define a mathematical or construct a mathematical model? Now here, first, from the real world, take a problem and define it. And go for the assessment. Go for the model assessment. Assessment is whether whatever you have done that is perfect or any modifications are required. Later on, publish your or report your results. So all these together give our research and completely this research will be based on brainstorming. Now we consider the construction of the mathematical model. Now we see how mathematics is used in the hands of scientists as well as engineers. In the hands of scientists, maths play a role of assimilating the data and understanding the phenomena. That's all. So what the scientists will do, they assimilate the data and they understand the phenomena. What phenomena is there behind this one? Now what engineers will do? Engineers For engineers, maths is a tool for decision making as well designing artifacts. Now, because of that reason, we call this as applied mathematics. So, application-oriented mathematics. This application-oriented mathematics completely will be used by the engineers irrespective of the branches. Also, it covers classical areas like mathematical physics, mathematical methods for engineers, with the advent of scientific computation and numerical simulations. See, without numerical simulation, scientific computation will not exist, because for scientific computation, definitely numerical simulations are required. Similarly, if only numerical simulation is there, if scientific, like vice versa, I mean to say, if scientific computation is there, numerical simulations are not there, further continuation will not be possible. And if numerical simulation is there, scientific computation, that means base is not there. If base is not there, you cannot move to the ladder, move on to the ladder. Now, modeling, computational simulation, and data analysis. These are the essential tools in engineering as well as technology and industries also. So as discussed, mathematical modeling and simulations as well, first data, and data analysis also very much required. Now here in this data analysis, what best we can do? First, when we collect the data, usually complete data may not be possible with us. So some gaps may be there. So what best we can do? We have to do the data cleaning. How we do the data cleaning part? Data cleaning part, for example, missing data is there. So when missing data is there, we can remove that particular row or column, or we can add some random number wherever the missing data is there, or we can go further, we can calculate the average of that particular row or column, and that average value may be kept in that missing part. So like this, we can clean the data, and then that data can be utilized for the experiments as well for practical purpose or for the research results. Now, mathematical sciences, it is completely connected to these areas. Not only these, few more also there, like probability, operations research, as discussed, economics and data sciences, artificial intelligence, right? So for all these areas, mathematical sciences are required. And here some areas have been mentioned. All these are already discussed. Now, fine. Continuously, we are saying that mathematics is used in real world. Maths is used for everyone. Likewise, we are using the statements. So how maths is used in real life situations as well for everyone. Let us see few examples, because we cannot cover each and every one, because maths is an ocean, it's the world. So we cannot cover each and every point, but few we'll try to complete or cover. Now in construction areas, for preparing the budgets, taking measurements, estimating the cost and profit, arithmetical calculations, geometry, calculus, statistics, trigonometry. See, arithmetic calculations, for all these first four, we apply geometry, calculus, statistics as well trigonometry. Similarly, for sports, we apply the maths areas like probability, mathematical operations and algorithms, logical reasoning as well game theory. Next, in fashion designing, basic mathematical operations, ration and percentage, geometry. Now actually here, when I'm giving this data, everyone please try to map the area as well, map application part or mathematical subdomain. Okay, try to map the area in the real world as well the mathematical subdomain. Try to map these, because everyone knows all these. Every day we experience this one. Now come to the next one, shopping at grocery stores and supermarkets. Actually, I just want to give a like brief information about this. Here, if we see mathematical operations, ratio, percentages, algebra, correlation, regression, basic statistics and probability we use in what way. And nowadays, lot of research is there, especially social media is very active now. So if you observe ratings for that particular supermarket, or if you can consider an example, films also, and as well any organizations, what is the rating given by the people who have already experienced the services of that particular area. Now here, if I consider the supermarket, a small example, suppose I consider bread, butter, cheese, sauce, jam, milk. These type of items I consider. Now the point is, because for all these expiry date will be there, a short period only, these items will survive. So the supermarket management, they cannot purchase lot many items. And at the same time, if shortage is there, their goodwill, they lost their goodwill. So in that scenario, what does they can do? So they apply some machine learning algorithms, and what they do, here, they do the categorization like bread with butter, bread with cheese, bread with sauce, bread with jam, bread with milk. Likewise, they do the combinations and what is the highest percentage of purchase of that combination. Similarly, single also they do. Here, what concept we are using is our power set. Singleton set, doublets, triplets, 4, 5, and so on till the last. So likewise, they do the 2 categorization, later on 3 categorization, 4, 5, and so on. And after that, what is the minimum support? So for minimum support value, they will calculate. Once after calculating, finally they come to a conclusion that where the demand is more. For the combination bread and milk, the demand is high, and similarly for bread and jam, the demand is high. So they have to purchase these 2 combinations a little high and the remaining items a little low. So likewise, they apply the mathematics as well, statistics as well, probability, and they come to one conclusion for the purchase orders, for giving the purchase orders. This is a small example, which is a very familiar example to all of us. And likewise, many things will be there. And if we come to the next, driving, those who are aware of driving definitely can understand these concepts, and you can map these 3 concepts with this driving area: logical reasoning, numerical reasoning, mathematical operations, like front view mirror, back mirror, as well front, right? From which mirror, like the front object or the back object, how much distance it is maintaining from your car or from your vehicle. So logically we'll come to a conclusion. So this much distance is there, so I can move a little ahead. And all these softwares have been also developed. For all those softwares, these are the main mathematical concepts which are used for that. Next, automobile industry, mathematical operations, ratios and proportions, statistics, geometry, algorithm. For computer applications, computations, algorithms, coding methods, cryptography, and so on. Here there is no limit, I can say, and so on. Exercising and trainings, basic mathematical operations. Here in this also, all of you, like those who are aware of all these tools which are used for exercising and trainings. All shapes, all mathematical shapes are available: dumbbell shapes, circles, rings, right? Many structures are available: squares and pentagon structures, hexagon structures, right? All these are available. Now, interior designing, geometry, ratio proportion, mathematical operation, calculus and statistics. Baking and cooking also, even for cooking also maths is used. Now, let us see few more concepts. Area of application in real world, name of the mathematics field used in this application. Here also the same concept. Every day we are using this, but exactly what math we are using in that part, probably all of us might be knowing. Maybe it's a kind of recalling session. Banking transactions, electronic mails, ticket reservations. Maths area is theoretical computational mathematics or the theory of automata and formal languages. Finite difference method, finite element method, all fluid mechanics. Most of us are doing the research in fluid mechanics. So differential as well, integral calculus or equations, computational mathematics. Telephone networks. Sir, am I audible? Am I clear?
Yes, madam, yes.
Okay. Yes, ma'am. Okay, thank you. Telephone networks, parallel connections for phone, gas, electricity, logical gates, job sequencing. All these we have experienced in our operations research, game theory, graph theory, right? So for that, all of us know discrete maths, graph theory, operations research, mechanics of solids and fluids in zero gravity, stability analysis, Chaos theory as dynamical system. Chaos theory is also very, very important, and it plays a major role in weather forecasting. Theory of fluids, application to meteorology, climatology, ocean engineering, complex environmental problems, global warming, and other geosocial issues. And for this, these are the sub areas. And for that math area used is balance models, stochastic climate models, hierarchies of intermediate complexity models. And similarly for airfoil design, problems of combustion, the area of maths is used is shock waves, hyperbolic equations, boundary layer problems, asymptotic developments, traveling waves, vector calculus. See, in all those, like more than 50% of the maths areas are well known to us. A few might not be knowing. Now, the next is modern physics. For that, what math is used? Group theory, renormalization, gauge theories, supersymmetry, Young-Miles equation, exotic geometries, topology in higher dimensions, tensor analysis. Out of all these, group theory is very familiar to us. Tensor analysis will of us know, topology in higher dimensions, and geometries. Geoscience, problems of resources and mining, environmental problems, climate research, pollution, transport in air, water, and soil, computational hydrology. The math field which is used, equations of extraction of groundwater, filtration, nonlinear systems of partial differential equations, and free boundary problems. Of this, partial differential equations is well-known topic for us, even free boundary problems also. Next, mathematics for seismic phenomena, wave propagations, and inverse problems. Material science, modeling, simulation, magnetic material polymers, and glass paper. For that, linear, non-linear elasticity, elastic property is used. And for nanotechnology, integrated optics, optical networks, quantum electronics and optics, nanotechnics in medicine, and porous material. These are the subdomains of nanotechnology. And the math used, the topics are coupling of quantum states, mesoscopic and continuum models, semi-classical Boltzmann theory, linear equations. Probably Boltzmann theory or all of us are aware of, and even linear equations also. Coupling of quantum states, physics people are aware of, I think. Now, large domain, in a large perspective, till now we have observed what maths is used. Now let us come to the specific area of engineering. And what is the subcategory of engineering? And in that subcategory, what maths is used? Right? So in a reverse pyramid way we are coming. First, complete worldwide. And first of all, what is the importance of this topic, why maths is important, and later on in a real world sense, and after that some examples, and now specific area of engineering. Now electrical engineering, AC circuits, all these problems we have done in our UG standards, and we are teaching to our BTech students as well, UG students also. The areas, logical gates, Boolean algebra. And the subcategory of engineering is resistor, inductors, capacitors, power engineering, analysis of electromagnetic fields and their interactions with materials and structures. Electronics engineering, digital signal processing, image processing. The math used is, and these are not limited, many more math areas are also used. These are not limited. Fourier series, transforms, RC circuits, mechanical or civil engineering, fluid flows, stress analysis, fluid mechanics, differential equations, integration, geometry, calculus, linear algebra, and more. Computer science and engineering, information technology. Computer graphics, in that zooming, rotations, transformations, animations, system modeling, digital communications, and the math area which is used for this graphics. They are linear algebra, probability statistics, calculus, cryptography, number theory, regression. See, actually here cryptography, number theory, regression, correlation, all these for IT as well CSC. For computer graphics, the names which are mentioned in the brackets. And apart from this, in computer graphics, neural networks, and for neural networks, lot of matrices is used, especially eigenvalues and eigenvectors. Complete neural networks is depending on eigenvalues and eigenvectors. Now, if we come to the next one, industrial engineering, steel industry, blast furnaces, prototypes. For car industries, we apply fluids, fluid mechanics, aerodynamics, materials, and fracture theory. And for this, we apply the materials as well, fracture theory and topology, even fluid mechanics. Fluid mechanics, once we use the word fluid mechanics, automatically differential equations as well, integral equations. Now, the foremost very important topic or area is biomedical engineering. Especially after COVID or during COVID or initial stage of COVID from 2020 March onwards, the importance of the pharmaceutical companies as well biomedical engineering is tremendously increased. What math area is used for this? Mathematical modeling and analysis of biomedical problems. So first of all, analyzation of the biomedical problem is very, very important. And lot of research went on and even going on related to COVID, and especially if we consider the statistical analysis based on the COVID itself, lot of research, many number of paper publications were there, and lot of projects are going on with respect to COVID 2020 phase 1, phase 2, phase 3, and with respect to region, with respect to gender, with respect to health complaints, and with respect to food habits, like vegetarians, non-vegetarians, with respect to area related, means like South India, North India, West, East, or state-wide or district-wide, and the general, it's not food habit, I mean to say food habits already considered. Apart from that, regular day-wise habit. So based on that, lot of research went on, and everywhere statistical models have been used. And in that, machine learning algorithms played a major role. And out of all those machine learning algorithms, SVM, decision theory, random forest algorithms, and KNN algorithms. So likewise, many algorithms have been applied, and all these algorithms like supervised algorithms, non-supervised algorithms, unsupervised algorithms, all these have been used, and especially in this linear regression and logistic regression, multilinear regression, right? All these concepts have been used while doing this research and analysis, and still it is going on. And the other point is numerical analysis for biomedical science and biomedical engineering, optimization techniques and computational methods for biomedical applications, mathematical models for bioelectromagnetic, biooptics, and neural engineering, inverse problems in biomedical imaging, including image reconstruction algorithm. Now here a point would like to specify biomedical imaging. Here, if you observe this biomedical imaging, first the scanning report or what is that, like heart-related diseases, the photo will be captured and that photo will be converted, or encoding and decoding will be converted, and that specific slide will be sent to the research laboratories, and there on that machine learning algorithms will be applied, right? So this is a very interesting area. Those who have interest in statistics, Python, and those who want to continue like in machine learning areas, definitely can opt this as a research topic. It's very important as well. Lot of research is going on. Not only here, even in defense areas also. This image processing is playing a major role, machine learning algorithms. Yeah, methods for biomedical image processing and visualization, computational methods for physiological signal processing. So all these are used under for the area of biomedical engineering. Now, let us see what is this lossy compression. All of us know about resizing as well, reducing the JPEG, compressing the JPEG format, similarly decompressing the JPEG image. So a lot of things we are doing nowadays. For every application, they will specify like below 15 MB or below 15 KB, even documents also, documents, JPEG formats, Word, PDF, whatever it is. So everywhere we are seeing. So what concept is there behind this one? What we use? Transform the image into a domain where compression can be performed more efficiently. So reduce interpixel redundancies. Here the basic point is, first we give the input image or document or whatever. It will construct n by n sub-images. Here we apply matrices. And again, forward transform. We apply the transforms here. Next, quantizer. That means again, they do some process here. Symbol encoder. Later on, finally, compressed image would come out. Now here a question is, once after compressing the image, would there be any difference between the original image as well compressed image? No, there will be no difference. But the point is, unwanted pixels will be deleted. That's it. In the compressed image, unwanted pixels will be deleted and there will be no difference in the formatting or the picture quality or whatever. There is no difference. Only unwanted pixels will be deleted. Now again, the reverse process, inverse, compressed image, symbol decoder, inverse transform will be applied here. Later on, merge n by n sub-images. Again, same. Here transforms will be applied and here matrices will be applied. And finally, a decompressed image would come out. Now, see, matrices as well transforms everywhere we teach. Basically, we are the teachers. Definitely, we have to teach in a proper way, question as well answer. But the point is, how can we create the interest among the students' fraternity? If the student knows the application of that mathematics area, for example, he is studying his computer science and engineering. So in what way maths is used in his particular domain? And especially the students definitely, they have lot of interest in these type of compressing images, decompressing images, as well machine learning algorithms or any artificial intelligence. In all these areas, students definitely will have their interest. The point is the connectivity, the mapping between their main domain and the math which is applied for that main domain. If you are able to give that, mapping between those two areas, automatically the interest will be generated, and soon we definitely can hear maths is very easy. We can handle maths, right? We never hear maths is a difficult task for us in that way. Now, maths in medicine. Already discussed a lot. A few CT scanning. Lot of new geometry and other math was developed to improve the quality of these scanning pictures, other medical measurements. And this is protein modeling. You can see the graphics also in this, and lot of geometry, combinatorics, topology will be used to design the shape for many drugs as well, motion of the protein. Maths is used in music also. The basic concepts or basic mathematical areas which are used in music are set theory, abstract algebra, and number theory. Also, to understand musical scales, some composers incorporated the golden ratio as well as Fibonacci numbers also. Fibonacci numbers, a very familiar mathematical topic, which is very much used in discrete mathematics, right? Yeah. A few more. All these are very familiar. Just want to skip only one or two. We just see basswood samples. This is our woodwork, carpenter works, carving models, right? In that, fitting the data with linear and polynomial functions. So polynomial functions is used, or linear functions are used for this particular area. Next, temperature in any specific areas. Many problems we discussed with our first BTech students or UG students, Newton cooling, right? And uranium examples. Yes. Next, beam analysis in mechanics. Piecewise linear, quadratic, and cubic functions, differentiability of the function. These maths areas are used for this. And till now, what areas are used we discussed. What engineering branch require what mathematics area. And now what formulas, few formulas we discuss, and formulas related to that particular area. Forensic mechanism, all of us know this. Catching a speeding motorist. For that, these forensic evidences will be there: skid marks, witness statements, collision damage. Suppose some accident is placed in on some road. So these are the tire images. So based on this, they will calculate the speed. First, based on this one, brake force they can assume, and distance of the skid also. And finally, by using these formulae, they can find out the that person's speed, with what speed he drove the car. And one more example, microwave cooking. What gets hotter, outside of the foot or the inside? Heating by microwave radiation constitutes a highly coupled nonlinear problem. So nonlinear problem we have to solve, especially Maxwell equations we apply for this microwave cooking. This is the thermal image of surface of food after 5 minutes heating. So first the outside surface will be hottened and later on inside part will be. So in this way the heat will be moving into the the next point is differential equation, initial condition. Solving the Maxwell equations for electric field predicts that the power absorbed decays exponentially. Temperature T satisfies a differential equation. So here the challenge is solve this in general and solve at steady state. So these two we can solve the differential equations in general as well steady state by using the Maxwell equations. So this is the math concept behind microwave cooking. Now one more. These are the parametric equations. X comma y point, any point on this packing and folding rocks. This is a very important theory. You can search Google for this. Catastrophic theory. So based on this one, you can find out any point on the folding as well packing racks. Next, the other general areas, weather as well global warming. So weather, meteorologists, they discovered chaotic behavior in a simple model of the weather. This realization had enormous impact on the use of modern mathematics for analyzing the weather, climate changes, and fluctuations in the stock market also. Similarly, global warming, catastrophic theory helps explain these instabilities. So what are those instabilities? 80% of the floating iceberg is hidden below the ocean surface. With what speed it melts? As this part melts, the iceberg can become unstable. So what is that instability ratio? At what time it will become unstable? To what extent it will sustain? So all these calculations will be used for this global warming. And here this meteorology is more than just presenting the weather. The role involves studying weather conditions using data collected from weather stations, radars, remote sensors, satellite images across the globe. And here, what type of skills are used? Excellent IT skills, as well strong skills in analyzing, interpreting the complex mathematical data. So all these are required to find. Now, aerodynamics as well as gene research. Aerodynamics. Now here, if you observe, understanding the way air flows around the wing. If the pilot do not understanding the air flows around the wing, automatically the problems will arise. Now, to reduce the aircraft noise over populated areas. So noise reduction is also very important. So for this, maths is used. And DNA, new mathematical techniques are being used to analyze the data. This analyzation is vital for the development of new medicines in the fight against viral disease. Again, same COVID example we can consider for this. Now, this aircraft, we can see this structure and with what speed it has to land, with what speed it has to move over the runway. Similarly, in the air, what speed has to be maintained. For all those maths equations are used. Tsunamis. Next, water vapor mixes into the eye of the hurricanes, just as cream mixes into the stirred cup of coffee. So for these two, same type of maths is used. Hurricanes, tsunamis, whatnot. See, all these are the regular words which we hear in the real life situations. Now in engineering, shapes, hyperboloid of revolution, Didcot power station. With this structure, they have developed this structure based on their requirement. Now let us see the very important areas wherein maths is used. Mathematics for artificial intelligence, machine learning, and data sciences. What are the main domains used for this AI, ML, and data science? Linear algebra, probability statistics, optimization, and deep learning. Next, artificial intelligence, machine learning, data science, deep learning, all these are interrelated. And especially for maths, these topics, statistics, linear algebra, calculus, play a major role. And for programming, data management software systems, and DevOps. These are the important areas for programming. Now, what skills to be built to get a career in artificial intelligence? Now, if we observe, sound mathematical and algorithmic understanding, efficiency in data science, well-versed with machine learning. See, if we observe these three, 1, 2, 3 diagonal, everywhere completely maths is involved. ML is based on maths, data science on maths, and algorithmic understanding maths. See, this is different, and here also a little different. These three skills are used. Now come to this artificial intelligence. First, let us take maths because this is our topic. Philosophy, biology, neuron sciences, psychology, computer science, and sociology. Now the interesting point is this philosophy, biology already discussed in what way maths is used. Neuron science, neural networks discussed. Sociology, I'll show you one example how maths is used for Facebook and social media networks. Next, computer science already discussed. Psychology, even for psychology, maths is very much used. Fine. Now, maths is at the core of AI and machine learning because it provides means for implementing how their goals can be reached. Artificial intelligence is heavily dependent on statistics, which also requires linear algebra, calculus to make any sense. So without linear algebra, statistics, and calculus, we cannot move further to improve the skills in artificial intelligence. Now, one of the best example, self-driving cars. Now here, pattern recognition. Here we apply the machine learning techniques, supervised as well unsupervised techniques. What is the inner science behind this one? Supervised algorithms as well unsupervised algorithms also will be fixed into this self-driving car system. Now here all the patterns like objects, images, car image, human being, whatnot, everything will be fixed. So what AI technique will be implemented here is, it will see the road and it will recognize the opposite image, and this will map with the images whatever it has. So this is here a car image is there. Fine. Okay. Already a car image is there. It is fixed in the system. So it will correlate. So correlation analysis. It will correlate with this image of this car, and then it will identify the, yeah, I should not hit this one. It will move its direction. Similarly, a human being or some animal or some cart, anything, it will identify, and then it changes its direction and it changes its speed also. So in that way, maths is applied in this self-driving cars. This is why probability optimization techniques are crucial for AI and machine learning. So here, what techniques, what maths techniques are used? Optimization techniques, because it has to it has to identify that image. It has to map in a optimized way, right? So if optimized solution comes, then only a perfection will be possible. It will not hit the opposite object. Because it shows us how to solve very difficult, deep, abstract problems. It does that by using methods and techniques already known. So here, already I'm using the word supervised learning. So in that supervised learning, labeled data will be there, and it will give the feedback to the system. So for example, if any object is in front of the car, it will give its feedback. Yeah, some object is in front of you, so you have to change your direction. Likewise, it gives its feedback. And apart from that, it is a, hello, any problem? Hope everything is okay. Okay. For this, we apply logistic regression also, logistic linear regression, and so on. Now, because of all these reasons, mathematics gives us a powerful answer in form of minimization procedures and backpropagation, which have been known independently for a long time. Some disturbance is coming. Just a moment. Participants kindly mute. Sherlyn, Nisha, I think, kindly mute. Okay, thank you so much. Now, yes, come to the data science. So what are the areas which are mapped with data science? Data research, data consulting, real world applications, scientific methods, visualization, statistical modeling, statistical computing, and data technology. Now here, if you observe statistical modeling, statistical computing directly related to our statistic area. Next, data technology. Here we go for the, already I have given, right, like cleaning the data, and here visualizing the data. So visualizing the data, it contains bar charts, pie charts, and graphs, linear as well, non-linear graphs. All those will come under visualization. Now, scientific methods, what kind of algorithms you have to apply, and what are the real world applications for this particular area, and consulting the data, data research. All these are the related topics for data science. Now, this is already, this maths part already we have discussed, linear algebra as well, calculus. Now, statistics, descriptive statistics as well, inferential statistics. These two areas we apply for, or we use for this data science. Now, Till now, we consider the major domains. Now, let us see the subdomains as well, subtopics, what all used for this data science. You consider linear algebra, linear equations, matrices, matrices decomposition, relations, computations, vector spaces, structures, multilinear algebra, also dimensions, eigenvalues and eigenvectors, inner products and norms, linear regression, principal component analysis, singular value decomposition, power methods, linear classifications. So all these sub areas or topics, I can say, these are the domains, subdomains as well, topics. All these areas are used in data science. Calculus. Under this calculus domain, limits, differential calculus, integral equations, special functions, numbers, series, maxima minima, mean value theorems. These topics are used. Descriptive statistics, statistical analysis, univariate and bivariate analysis. Next, inferential statistics, statistical models, statistical assumptions, appropriate distributions, approximate theory, randomization based models, and model based analysis of randomized experiments. See, out of all these, majority points are well known to us. We are teaching almost every topic to students. But the point is the connectivity. That is only the missing concept. So each and every point, what are the complex problems related to this particular area, or what are the engineering applications for this particular area? See, these points, not only for data science, these points are used for almost all engineering branches. So branch-wise analysis we can make out, like for this particular branch, what type of maths is used, or what is the mapping between the branch as well that maths subdomain. Likewise, we can. Now, a very important concept which is used in many engineering branches is principal component analysis. Lot of data is generated daily. If you consider the social networks, Facebook, Twitter, Instagram, whatnot, anything, any social media, if you consider, lot of data is generated. In fact, 90% of the data is generated in last 3 to 4 years. Data is to be properly analyzed to gather important and relevant information. Here the point is, if you have not gathered the information properly, our results may go wrong. So to get the optimized solution or optimized answer or result, definitely we have to do the proper analysis. So for that analysis, this principal component analysis is very much used. So this PCA, this is a dimension reduction technique which gives most dominant features from the data. So many, see, when we collect the data, for example, some Excel sheet is there with us, many features, many attributes will be there. Out of them, few may be very much relevant and few can be neglected. They may be neglected. So based on that, this PCA analysis, this works out and it will identify the very important features, and those features, those newly extracted features are called principal components. So multivariate calculus, whatnot, any subdomain in our engineering branches or real world. Principal component and pictures, pixel data. This also considered lossy compression, right? Already we discussed an example also. Encoding of the data set, singular value decomposition, later deals in world problems. Now here, let us see a small example wherein the importance of the partial differentiation. See, all of us know the partial differentiation as well, partial differential equations also, and we applied in our research in many areas. Now let us consider a small problem. For example, this is a car. You want to do, or you want to make over the outside surface of the car, but not the inside. You don't want to touch inside area. You don't want to do any modification for the inside area, but only the outside part. Maybe bonnet, maybe the tires, maybe the window glasses, maybe the backside, right? Or top side, some change in the color, right? And so likewise, so only outer part you want to do some changes. So what best we can do is in that program or in the equation, you will change only the variable which is related to the outside portion of the car, right? So you change only what is necessary, need not change each and every variable, because this is the partial differentiation. You do not change anything else, even though they can be. So inside portions also you can change, but because they are not required to you, you will never touch those variables. You will touch the variables which are very much related to the outside portion of the car. Like you can you add windshields, you can add, change the body if necessary, add air vents wherever necessary. So likewise, outside part, like some more additions may be there to the outside portion. For this, partial differentiation is very much useful. Now, and this partial differential equations or partial differentiation, we are discussing for in this especially programming area, right? We consider the program and we change that variable wherever it is necessary. Multivariate calculus and applications. Jacobian. All of us know the importance of the Jacobian. Jacobian helps to find the global maximum of the data set. Also helps in linearizing a non-linear function to linear at a point. So sometimes it is very important to convert a non-linear function or equation to linear equation. So that can be done by the Jacobians. Even global maxima as well, global minima, both also can be calculated. So with this, we understood that the maxima minima also will play a major role in engineering applications. Next, Hessian function used in deep learning models. This multivariate calculus used in deep learning models. Gradient descent method. This is very, very important. Gradient descent method for optimizing weights. So this gradient descent method, this is used in data science, used in machine learning, whatnot, in many areas, neural networks, everywhere it is used. Now come to the again subdomains: linear regression, multiple linear regression, logistic regression. Now we just discuss the real world problems. In what way this regression is used? Very interesting example is in any organization, one employee, he performed well in the last quarter. How much raise should he get? Increment. How much increment he can expect? It is a statistical method that helps to find the relationship between an independent and dependent variables, both of which are continuous. So here, what are the independent variables and what are the dependent variables? Now here, all of us know the word API, Academic Performance Indicator. So in that, what is your contribution towards research? What is your contribution towards academics? What is your contribution towards administration? And what is your contribution to the extracurricular activities? So likewise, categorization is there. So everything is subdivided. So those are all the independent variables. So research contribution, like papers, books, chapters, so all those. So for example, one paper is increased, automatically your API score will be increased. So all these points are dependent variables and your score all these are independent variables and your score is the dependent. So once if your one point is changed, one paper has been added, 10 marks suppose have been added, your score is increased. Similarly, a book chapter is added, or one like this, resource persons or anything, whatnot, anything you can consider. So now, what is a simple linear regression and what is a multiple linear regression? All of us know this equation, y is equal to mx plus c. Not many problems we have done, and least square method we come across with this statistics part. Even multiple linear regression also we come across. These are the independent variables and this is the coefficient, all the m1, m2 are these are the slopes. Now, here if you observe, this is the employee rating and this is the salary hike. So if the employee rating is 1 around, then hike may be around 5K suppose. And suppose employee rating is 2 out of a scale of 5, salary may be 10K and so on. Now here all these points, these points are scattered. So here all these different rating points are considered, and based on these points a linear line will be drawn. And here, if you consider the least square method, what is the least square method? Why that name has come, right? Here, the points, if you observe, this is your line, right? Kindly, you participants, one of you have been unmuted. Yeah, thank you so much. Yes. So least square method, the distance is here. This is actually an error because the line has been drawn in this way. It has not joined all these points. So these points only are there over the line. So these points only will affect the dependent variable. But many points are there outside. So what best we can do is we calculate the distance between and we try to reduce the gap between these, the point on the line. That means actually here the point is not there. So what I can do, this one, and similarly here, this one. So distance between those two, squares of those two, and finally least squares. Out of that, consider the least square. So based on that least square method, you can draw the linear line and y is equal to mx plus c, and you can find out the salary hikes based on the employee ratings. Now, come to the linear as well logistic regression. First of all, let us see this point. Here in this logistic regression, suppose a car you are considering. Okay, so probability of breakdown of the car and regression model created based on other users' experience. So yours since experience, you have already created a model based on the previous experience. After how many years a so-and-so company car will break down, and what is that probability of breaking down within 1 year, 2 years, 3 years, and so on. Now, here if you observe, probability, if the probability is greater than 0.50, see this point, it is showing 0.9, above 0.5. So 0.5 onwards, this is the threshold value. From this onwards, there is the possibility of breakdown. So from this point onwards, the car may break down anytime. This is the threshold value. Here, that means 0.5 above. So usually, like for example, if you consider the car maintenance and on, 15 years service, if 15 years service is crossed or 1 lakh kilometers is crossed, then the car may break down and you have to change the car. That is the instruction given by the government. Now, even after 1 lakh also the car will run. That means the probability point is here. So it is not breaking down. Similarly, for example, it is crossed 15 years, 16 years, 17 years like that. It may run, but there is a possibility. Means you are in risk, you are taking risk. And once if it is crossed, so obviously you are at a maximum risky zone, and definitely it will break down. Now, threshold value is 0.5, right? Now, suppose probability is less than 0.5. The value rounded up to 0, the car will not break down, right? Because it is less than 0.50. Now, come to the next. The math behind logistic regression. We calculate odds. All of us know probability of happening of an event and not happening of an event. Theta is equal to P by 1 minus P. And take the equation of the straight line here. That equation is y equal to b naught plus beta naught plus beta 1 x. And p of x by 1 minus p of x. This is your theta value. Log theta is equal to your equation. Y is equal to beta naught plus beta 1 x. Now apply exponential to both sides. E to the power of ln of this is equal to e power beta naught plus beta 1 x. Then you will get p of x by 1 minus p of x, which is equal to e to the power of beta naught plus beta 1 x. Right? Now, suppose this value is capital Y. So capital Y is equal to e to the power of beta naught plus beta 1 x, and p of x by 1 minus p of x, suppose it as y because These two are equal, and do the simplification part. Finally, you will get P of x is equal to 1 by 1 plus e to the power of minus beta naught plus beta 1x. This is called sigmoid function. Very, very, very important for entropy and information gain. Now, logistic regression applications, weather prediction and healthcare. So here if you observe revised trauma score, what is the RTS score and what is ISS score and what is the age based on the age, and definitely you can calculate the patient survival. Similarly, the applications, image categorization. This one already we checked in that self-driverless car, image identification. Next, this is very, very known topic to us, hypothesis testing. Statistics is an area of applied mathematics concerned with the data collection, analysis, interpretation, and presentation. Your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? So, we are doing the testing hypothesis. Yes. So, sampling, two categories, probability and non-probability. Under probability category, random stratified and systematic also. For non-probability, snowball, convenience, judgment, and quota. So these are the categories. And this already we considered two types of statistics, descriptive statistics and inferential statistics. Descriptive statistics, it mainly focuses on the characteristics of the data, that's all. So it provides the graphical summary of the data. That means maximum number, average number, minimum values. So likewise, it speaks about the characteristics. Similarly, it will show the graphical representation, graphical summary also. Under this descriptive statistics, let us see gain as well entropy. This is the entropy formula. Okay, and this is the information gain formula. These two are very, very important for data science as well, machine learning. And one more very important concept is confusion matrix. This confusion matrix, see, some concepts we have already done in our type 1, type 2 errors. Okay, so that formula, the main formula is true positives plus true negatives divided by true TP, TN, FP, FN. This is the confusion matrix formula. Now just observe this part. Okay, and here what is true positive? True positive, there are cases in which we predict yes. So it is positive, right? And we predicted the same. Okay. Now true negative, we predicted no, and they do not have the disease. They don't have negative, and we predicted the correct one. False positive, we predicted yes, we predicted as positive, but it is wrong. So it is called false positive, which is very parallel to our type 1 error. False negative, predicted no, but it is false, right? We predicted no, but it is false, which is similar to type 2 error. Now, inferential statistics. These two are also very familiar to us, point estimation and interval estimation. Now, see, if you observe, actually, these concepts are taken from data science as well, machine learning part, but everything is our mathematics as well, our statistics, and we are teaching to the students, but unknowingly. Point estimation, interval estimation, we are teaching. And similarly, type 1, type 2 errors, we are teaching. And okay, fine, confusion matrix not, but these formulas, some way or other, we are using in probability statistics, right? So, point estimate and interval estimate. This is the population, and this is a small sample. Randomly, we pick this sample from any place, either this one or this, any sample you can pick. And then you will estimate, right? The estimation values are the sample means and sample standard deviations and variance, all those sample values we will. And here the point is which sample we are considering. So based on that sample only, we will get the best results. For example, the sample is very poor. Obviously, optimum solution we will not get. So picking the sample is also very, very important. So if I consider only this sample, I can predict the mentality or the results of this particular north area, that's all. But instead, if I pick up a few members from this area, few from this area, from here, here, here. Likewise, randomly we pick some people, and if I make it as a sample, then obviously the optimization results will be there, and the like whatever we are expecting, that will be definitely happen. Now, point estimate, interval estimate, here if you observe, lower confidence limit, and this is upper confidence, and the leftover is the interval estimate. Now, this one, like in point estimate as well interval estimate, what concepts we use? Bayes estimators, best unbiased estimators, maximum of like all these names we are aware of. Now here in interval estimate, this biomedical or general biology examples, if we consider BP ranges or sugar range or any test, any diagnostic center, if we go, lipid profile tests, any test, if we come across, obviously a range will be given, like suppose 70 to 90 or some 100 to some 200, these type of some range will be mentioned. What is the need to give the range? Why can't we give 150 exactly? Because it is not possible. The reason behind that is, again, the partial differentiation will come into picture. At that particular moment, a person has taken a small quantity of minute quantity of sweet. Automatically, the sugar levels will be changed, but it is not dangerous, right? So maybe some plus or minus 10 variation will be there. Similarly, even BP also, because of that specific environment, the person's BP may shoot up, or it may come down based on the any information what he heard from the outside. So it is not dangerous, right? But have to take care. And one more thing is, the BP can be fluctuated in between these two values. Likewise, a range will be fixed. This is the importance of the interval estimate, because if we give a specific value, for example, 150, if you mention for any BP level or something, if it crosses or if it is 155, the person will shiver. My God, my BP level is 155. I'm in a dangerous situation. So, but it is not. So that is why range values will be mentioned. That is the importance of the interval estimation. And Facebook global advertising. Now here, if you see, this is our parabola. Y is equal to ax square plus bx plus c. Now you can observe time spent online and Facebook friends, right? How much time online is there and Facebook friends. Now here a normalized curve will be, and this is the R square is the correlation coefficient. And if you substitute some x value, any friend details, automatically you can calculate this y value, how much time he or she has spent online. And maths is used in curriculum and education also, STEM. All of us know the word STEM: science, technology, engineering, and mathematics. And importance of game theory. Game theory is a part of maths. So game theory is used in economics, political science, biology, sports, and all these are the subfields. Engineering, electronics and communication, computer science, electrical engineering, civil engineering. In all these areas, game theory is used, and these are the subdomains. And come to discrete mathematics. Most of us are well versed with this discrete mathematics. Set theory, logical gates, matrices, and graph theory, right? And isomorphisms. Okay. In every area, even examples, if you consider data structures, design of algorithms and analysis, digital logic designs, artificial intelligence, network securities, graphics, DBMS, everywhere this discrete mathematics is used. And see, if we observe, we are taking the subdomains of the mathematics, a specific area we are considering. So developments such as converting the problems of real world to computer technology and creating algorithms by using Boolean algebra, as well supporting software applications. Now, very important concept, one more important concept is cryptography. So applications of cryptography, if you observe, digital currencies, computer passwords, military communications, money transfers, storing passwords, qualification, end-to-end encryption, secure communication, authentication, cryptocurrency. This word nowadays we are hearing a lot. Cryptocurrency, electronic signatures. This also we are using nowadays. time stamping, cash withdrawals from ATMs, everything nowadays, every point we are using now. So for that, what is the procedure? A plain text is there, a public key will be. This public key, for example, like P mod M is there, for example, congruence functions. Now what we do is P plus 3 mod M. That means we are adding 3 to that. First, what is the basic concept is, all of us know that coding and encoding, A to Z numbers we will give, 26 numbers. After that, one code will be given to us and one key, public key. For example, this 3 is the public key here. Okay, and this equation, congruence equation will be given. So what we have to do is, to this code, we have to add to this, add 3 to all these numbers. So automatically, after adding, numbers will be changed, leading to change in the alphabets, right? And later on, again, decryption. In that decryption part, P minus 3 will be used. And then P minus 3 means, again, the numbers will be changed, again, the letters will be changed, and finally, coding as well as decoding as well as encoding, both will be completed. So this is the public key and this is the private key. One public key will be there and one more private key also will be there for decryption. This is called, all of us know this concept, ciphertext. This function only I have used here, P plus 3 mod M. Fine. Now, Boolean algebra in constructive solid geometry. A union B, A intersection B, A minus B, all these concepts we know, correct? So how can we write AI intersection BI in the geometries? So how can we construct the new models? Already we spoke much about this in protein development, new geometries have been designed and defined. So what are the new geometries, how they will be defined and designed? So there Boolean algebra is used, A intersection A minus B minus, AB intersection B, B, and so on. Okay, and this is the regularized Boolean set operations. So this one is mapped with A union B, and this is mapped with this one only, and this is mapped with these, and here with these two likewise. Okay, and here if you observe, after A union B, this is the new structure, new geometry. That means new shape. Okay, and this shape name we know, this shape name also we know, cylindrical structure and cubical structure. Once after mixing these two, joining these two, we call adding, combining, joining, merging. So new shape has been developed. Similarly, A minus B. This is the new shape which is developed by the difference. And one more, all of us know this binary system, hexadecimal system, as well octal system. So binary to decimal system, binary to hexadecimal system, binary to octal system. Likewise, we can convert. And here this is, if you observe, this is the logical structure that is converted into the matrices, right? And everywhere 0, 1 will be used because it is the binary system. And vectors and trigonometry, importance of vectors and trigonometry in engineering applications, mechanical engineering, civil engineering, electrical and electronic engineering, energy system engineering. These are the sub areas wherein maths is used. Maths in the sense vectors and trigonometry, these two concepts are used. And other very important areas are intelligent analysis, OR, statistical reasoning, research, logistics, financial analysis, and so on. And coding and security, ATM pin generation, number theory is used. And this is very interesting actually. Honeycomb, hexagonal structure. Why only hexagonal structure? Hexagonal 6-sided cells. Squares also, see, squares also may be there. Why not squares? The reason is squares would also fill the space, but would not give a rigid structure. Is the problem. And next, triangles. Triangle would fill the space and be rigid, but it would be difficult to get honey out of their corners. See the environment, God's creation. So hexagonal structure, hexagonal cells only are the perfect ones. So this one, hexagonal structure. Okay. Yeah. Next, rotational symmetry in globe, understanding percentages, symmetry in tower, geometry in civil industry, lines and planes, cubes and cones, parallelograms, right? All these are the real world applications wherein maths is very much used. and spheres and cubes, pyramids, rectangles, circles, geometry in CAD, structural engineering. Structural engineering, what shapes are rigid or flexible, how they respond to forces and stress. So based on that only the structure has to be developed, right? With the environment, how strong it would be for tsunamis as well, for any other problems. Yes, what is the rigidity for the stresses as well forces, and graphics I'll show you. Now one more maths in biology, symmetry system, maths in forensics. Blur image will be converted, and for this we apply differentiation as well integral calculus, differential calculus as well integral calculus for forensics for image processing. Next one, the air shock of atomic bomb. These are the shapes at time 0.006 seconds, 0.016 seconds, 0.025 seconds, 0.053 seconds. These are the shapes of the air shock of the atomic bomb. And how to calculate? This is the maths involved in that. And image recognition of computer tomography. So here, what maths is used for? Tomography is very, very important, computer tomography nowadays. So important maths is you can observe the equations and you apply the, here, you apply the Fourier transforms, and variable transformation is also there, matrices you apply, and finally polar coordinates. So this is the maths involved in this PT technology. Okay, and maths in labs. So laboratory experiments to construct. Interest in its development and applications leads to the establishment of the big institutes, a tremendous improvement in computational biology. Mathematics satisfies all the individual needs, organizational, business needs, national needs, as well as universal needs. That is why many laboratories have to be constructed for all the areas like medicine, biology, environment problems, reduce the environment problems, industries, and whatnot, car industries, engineering, communication. So everywhere maths is utilized. Now maths in defense sector. In what way maths is used in defense sector? Mathematical sciences are used in planning, logistics, deployment, and scenario evaluations for complex operations. Cutting edge mathematics and statistics lie behind smart sensors and advanced control and communications. You see, advanced communications and control systems are very much used in the defense sectors. So there mathematics is used, and even for this also deployment and scenario evaluations. Mathematics in other fields. Mathematical simulations allow predictions of the spread of smoke. So smoke can be reduced. And here mathematics and statistics underpin tools for control and communications in tactical operations. So this one already we have come across with artificial intelligence, machine learning, and so on. And maths is used to design advanced machinery, right? Advanced machinery constructions also. And finally, how maths is used in computer graphics. So a lot of maths is used in computer graphics. First one, digital differential algorithm, complete mathematics algorithm, line drawing, Bresenham line algorithm, circle generating algorithm, midpoint circle drawing algorithm, ellipse generating algorithm, transformations, translation, scaling, and rotation. Now here the main concept is, see, if you ask me to draw a circle, I will draw in this way on my screen, right? But how can you draw in the system, right? How can you generate a circle on a system, on a Word document? How can you generate? Not drawing, not the manual drawing. How can you generate? So for that, circle generating algorithms are available. If you apply that algorithm, automatically the circle will be placed over the sheet. Similarly, sphere generating algorithms, line generating algorithms. Okay. And now just see very few examples. Translation, For example, an object is here on the plane. Now, after translating, the object is here. It is on the x-axis, right? You can change the position of the object by using translations. Okay, we always see in computer graphics, head, automatically it will be rotating, and sometimes head is a different person's, right? Different person's head holding with the body. So all these are possible in computer graphics because of these rotations, scaling, translations, right? So for example, if I want to remove the head, what I do, I just remove from that and I'll place the another one involved in this. So x dash is equal to x plus tx. Okay, translation we are using, right? So these equations are converted into matrices. Then the points are there, no? 1, 2, 3, 4, 5 points. So this point, and I'll substitute in here. So automatically the positions will be changed. So x dash point will be some other, right? Previously x point is different. Now x dash is different and y dash is also different. So we apply this translation for the movement of the object. Similarly, scaling. So here this is a big object and here this is a small. So it is scaled, like resizing, I can say, right? Similarly, rotating. Here the object is like this. Now I have rotated, and what maths concepts are used here? So this is the point P and this is Sx, Sy, these are the coordinates. And the point, suppose the point is here, P point is here. Now with respect to the P point, I'll apply the scaling, and the new point I got 1.4, 2.2 point has been changed to, okay, 4.2 and 6.6. So here actually increment is there. So say, for example, this is the before one, this is the after one. After applying the scaling, the shape may be changed in this way. A small, only one point I have taken here as an example. For all points, you can apply the same thing. Automatically, the position will be converted. Now rotation, same concept. The maths involved is here, this one. Okay. And next, Hermite cubic curves, Hermite surfaces. A very, very important concept in computer graphics. And here also Hermite polynomials, Hermite curves. Already we heard many about. Hermite surfaces are completely defined by 4x4 geometry matrix. Hermite cubic curve, 2 endpoints and 2 endpoint tangents. These are the points and these are the tangents. And here 4 points, right? And 4x4 geometric matrix. Next, similarly, cubic Bezier curves, B-splines. Those are also very important for graphics. Okay, 4 control points will be there for the curve. Okay, and here also 4 controlling points. Bezier blending functions, these are. And what maths is used here? This is, all of us know this binomial, right? Cn of I to the power of t to the power of I, 1 minus t to the power of n minus I, odds, evens, and okay. Next, different primitives can be handled in different ways. Now here, example I can give you as cropping. Okay, cropping every day we are using, right? Even now for these slides also, I have applied cropping only. So these are the viewport, okay, viewport coordinates. This is first one. This is the window mapping to viewport. That means world coordinates are converted to viewport coordinates. For example, we have taken a photo with by using our mobile. Later on, we want to crop it. Okay. After cropping, we will get a clarity picture, and wherein we remove the unwanted areas, and we will have this picture only with us. This everything will be deleted. This is also we have experienced in our mobile as well, even in our laptop also, while cropping the Word documents or any PPTs or anything. And in mobiles, photos and sharing transformations. Now here, if you see, this is the unit cube. Suppose if we share in X direction, like this, it is changed. Okay, squeezing as well as zooming, right, in one particular direction. This is shared in Y direction, shared in both X and Y directions, right? This would be the ultimate shape of the unit cube after sharing, right? And for that, these are the matrices have to be used. And rotation, you can observe this picture, rotation in 3D. This is the original picture. After rotation, this is the structure. Okay, clear evidence here. Rotation about z-axis. You could see even that also, about z-axis, x, y, z. About z-axis, the change is identified. And scaling, this is the original picture. Scaling in y direction, see the shape, enlarged with respect to y-axis. And here scaling all axes with respect to x, y, z. And for that, what matrices are used means this one. Sx 0, 0, 0, and so on. These type of matrices are used for scaling. So with this, I'll just close the session. Use your skills and talent to solve the problems of the world. Thank you so much for your patience. Thanks a lot. Any questions?
Very, very informative session, madam. Thank you very much for your knowledge. I'm very happy that your presentation. Thank you very much. If possible, please share your PPT, and I will appreciate your work that you have done for collection of all those. Thank you very much.
Thank you so much, sir. Thanks to your university management as well as for the organizations, especially to Gunashekhar sir for this tremendous 2 weeks FDP. Organizing 2 week FDP is not that much simple, but you have taken a lot of care to complete this one. And again, it is going on anyhow. Thank you so much, sir. Thanks for giving this opportunity. Thanks a lot.
Any other questions, audience? Ma'am, shall we conclude?
Yeah, yes, ma'am. Yes, ma'am.
Now we conclude this session with our vote of thanks. Thank you so much, ma'am, for your outstanding presentation. You provided specific information about where mathematics is used, which is necessary for us to comprehend. Once again, thank you, ma'am. And I also extend my thanks to all the participants for your cooperation. Now this session is over, and next session will start at 2:45 p.m. Thank you.
Thank you, ma'am.
Thank you so much. Thank you all. Bye. See you again.
Thank you, ma'am.